It's Ariel, one of the greenhouse instructors from the Horticultural Society, and today we're going to talk about soil. Although many factors contribute to a thriving garden, all growers will emphasize the importance of good soil. In addition to anchoring roots, soil provides life-sustaining water and nutrients. Plants in poor soils will struggle to grow even if the best light and water conditions are available. In contrast, plants in good soils will grow to their fullest potential and experience fewer problems with insects and disease. Soil is composed of air, water, minerals, and organic, or living, matter. Today, we will be getting deeper into the mineral particles of soil. Sand, silt, and clay are the three mineral components of soil. They are derived from Earth's bedrock that is broken down over thousands of years by climatic and environmental conditions. Years of rain, wind, and water erosion, plus animal and human impacts have broken down rock in particular ways to make up our soil. Because this process happens all over the world in particular ways with the particular rock of that place, the soil texture and composition in each place on Earth is pretty unique. The largest, coarsest mineral particles are sand, and they feel gritty in your fingers, similar to the sand that you would find at the beach. Silt particles are smaller and feel similar to flour. Clay particles are extremely fine and small and feel sticky in your fingers when wet, and clump together to the point that you can't see an individual particle without a microscope. Soils don't usually contain just one type of mineral, rather they contain a mix. The proportion of the different sized soil particles determine its texture or the way it feels, and affects how the soil behaves, because it affects the amount of air, water, and nutrients available to plants. The smaller the soil particles, the more they stick together when wet. So clay soils can be sticky, wet, and difficult to work. With fewer air spaces, they drain poorly, and roots may suffer from a lack of oxygen. Plants can actually drown if the soil is too wet. However, clay soils can be rich in minerals too, and beneficial for plants. In contrast, sandy soils can drain water too quickly and be low in nutrients, but they are also easier to work with. Adding organic material can offset many of the problems associated with either extreme. We'll talk more about organic matter and composting next week. While there is no such thing as a perfect soil, particular plants grow best in particular soils. In general, common garden plants prefer a loam, soils with a balance of different size mineral particles, approximately 40% sand, 40% silt, and 20% clay, and also plenty of organic matter and airspace. But some common plants, like lavender, grow better in sandy conditions, while others, like echinacea, are well adapted to clay soil. Now that we have a little bit of background knowledge on soil and soil composition, we're going to go through two really easy experiments to test soil texture and soil composition. While these tests are not an exact science, and growers often do more exact soil testing by sending in samples to labs and universities, these simple tests give us a more working knowledge of our garden soil. So the first test is called a ribbon test, and the second test is called a mud shake. The ribbon test is an easy way to explore soil texture and estimate the amount of each type of soil component present in our soil samples. So first we're doing the ribbon test. So first things first, you take a small amount from your soil sample. This one's coming from our community garden in East Flatbush. Add a little bit of water, just a little bit, and you can make a soil clump in your hand. And then between your fingers, you're going to make a ribbon. If it sticks together like this, your soil has a lot of clay in it. All those particles are going to stick together, forming kind of like a clay. So next we're going to test our store-bought topsoil. So again, take our soil sample, put it in the palm of our hand, add a little water, roll it into a ball, and then into a ribbon. It's falling a little bit apart, so that tells me it has a little bit more sand in it, but it is holding together, so it has, I think, a good mix between the soil and the clay and the silt, and that is called a loam. Soil that has a good mix between sand, silt, and clay is called a loam. So lastly, we're going to test the soil from our raised beds. So take a sample from the raised beds, add some water. I'm going to try to do it this way. Make a ball. Rub it between our fingers, and it's not even sticking together really. I might have added a little too much water, but it's really not able to stick together, and that kind of tells me that there might be a little too much sand in this soil. There's a lot of sand in this soil, so it's not able to stick together so much. Now we're going to see the 3 different components of our soil settle out by creating mud shakes. To do this experiment, all you really need is soil, or even a few different soil samples, water, a clear container, and optional is adding a little bit of laundry detergent. To create a mud shake, first fill a clear container about 2/3 of the way with water. Then add enough soil to nearly fill the jar. You can also add a pinch of laundry detergent to help the soil components separate well. Then shake the jar vigorously. Shake, 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 shake. Now put the jar down on a flat surface and observe the jar over the next couple of days as the soil particles settle into layers. Looking at our settled mud shake jars, the largest particles are sand, and they are the heaviest too, so they will always be at the bottom, followed by silt and the last layer being clay. The clay may also stay suspended and cloud the water for a long time. Organic matter is the lightest and will float or stay just above the water surface. Once the jars have settled, we can also compare our results to our ribbon tests. Do what we see in the jars confirm or contradict our results that we saw in our ribbon tests? Our jar from the Flatbush Community Garden shows a smaller layer of sand and a larger layer of both silt and clay, which confirms our ribbon test when everything kind of stuck together like a clay. So this seems pretty accurate. The next is our jar of topsoil from a local nursery, and it's hard to see because of the glare, but we do see a lot more sand, right? There's a lot bigger layer of sand in this jar compared to the jar from the Flatbush Community Garden. And we did see that in our ribbon test, that this soil broke apart a little bit more easily. It didn't stick together as much. Lastly, this is our jar from my raised beds. This is a pretty interesting result. Looks like there is a lot of sand, but it does look like there's less sand than the topsoil. But I'm interested in that the water is clearer, which tells me there's not a lot of clay, which is why the soil maybe didn't stick together as much. This is a simple and fun way for us to get to know our soil structure a little better. When we get to know our soils better, we become better gardeners. Thanks for watching.